Hello, today we'll be looking at chapter 1 lesson 1 on this topic, mastery P&ID and other schematic for complete beginners, a practical approach on how to examine, interpret, draft P&ID and other schematics diagrams. Chapter 1 lesson 1 Introduction. The true meaning of engineering procedure is misplaced when a keyword remains uncertain to a professional or to the professional over their inability to represent, examine, and interpret engineering records or data in diagrammatic or mathematical forms. In a process plant environment, an in-depth knowledge and understanding of the process diagrams are necessary for the smooth operation and troubleshooting of industrial components. This diagram, this figure is for illustration purpose. It's a typical industrial process plant. However, the industrial equipment or industrial process plant or unit operation or equipment used in the industry differ from plant to plant, different from industry to industry. Nevertheless, it is crucial that technicians, operators, and engineers have an in-depth knowledge and understanding on how to present, examine, draft, and interpret engineering schematic in mathematical, graphical, or diagrammatic form for optimal operational performance of process line in an industrial environment. However, this work or this course cover but is not limited to the analysis of block flow diagram BFD, process flow diagram PFD, utility flow diagram UFD, process and instrumentation diagram P&ID, but also the definition of other schematics of interest in process plant as we go along. The book is 99% practical self-learning, flexible with practical example and case studies with real life or dummy project where necessary. Every equipment or unit in process plant have their true graphic symbols and P&IDs symbols when presented in the P&ID diagram. Take for example this figure 1.2. For illustration purpose, this is a pump and the P&ID symbol. However, this is actually a graphic representation of a pump, of a centrifugal pump, and these are the symbols, okay, the standard symbols, or what we call the P&ID symbols. These are the symbols. These symbols are the ones we actually see in the P&ID diagrams, not this graphic symbol. However, figure 1.3 show a typical simple P&ID, not to scale, but is for illustration purpose. Okay, so below show a P&ID diagram. Not much information is provided there in any way, although the diagram is not to scale. However, it shows an illustration of a typical unit. It can be an extra from a typical P&ID, or it can just be a unit operation P&ID diagram. However, as you can see, the labeling of this equipment is V100 is V-100-01. This photo section of a process unit here, as you can see, it shows different equipment. You can see a valve, you can see a pump, you can see thermocouple, you can see different equipment here. Anyway, it's just a section, it's not drawn to scale. So we're always trying to differentiate between a photo section of a plant, then the graphic symbols, so and the P&ID symbols. Okay, so a photo, graphic symbol, this is a photo section, then this is the P&ID standard symbol. So okay, figure 1.5 for illustration purpose is showing a pump P&ID symbols. Okay, here we have the graphic symbol, we have the standard P&ID symbols, which have been incorporated to this P&ID diagram. So when you look at the P&ID diagram, you see something like this, these symbols. That tells you is a centrifugal pump symbols, and then this is actually the graphic symbols of the centrifugal pumps. Anyone interested in P&ID drafting may need skills in P&ID card sketching software, as summarizes in Chapter 12. Nevertheless, the core objective of this work is to ensure that upon the successful completion of this self-learning, participants with ease can examine, interpret, and generate PFD, PFD, UFD, and P&ID using standard symbols and notation where necessary. Identify component of P&ID. Distinguish between a BFD, PFD, P&ID, and other schematics as compared to other engineering schematics. Master and learn the techniques to read and interpret industrial schematics. Understand the standard and code used in P&ID design. Appreciate the importance of schematic in engineering design and in the process plant commissioning. Know how to unravel engineering problem using schematics diagrams, because schematics diagrams are actually very important in engineering in troubleshooting in a process plant environment. After completing the self-learning contest, participants would have acquired good understanding of what P&ID is all about, and participants should feel very proud of getting the fundamental tools and skills and working knowledge of P&ID. Of course, there are still more to learn about P&IDs, but the skill acquired here should stand participants in a good stead. In this context, the frequent use of the phrase process plant as regard to this course encompasses all industrial plant where schematic diagrams are used. See you again in Chapter 2. Thank you.